Hello everyone. Thank you for coming to the seminar. For this seminar. The title is a Volcan AI. This is work with USGS and University of Hawai Hilo, and we also have we are planning to invite some of the people from Manoa, like Jason and Hao Peng, to make the project a little bit bigger so we can apply that to other problems as well. So it's the early stage because all this things going on at the federal government. So it's going slower than I expected, but it's going well. So I'm going to share where we are right now with the project. So a little bit about myself. My name is Sukwa Hong. I'm an associate professor of data science and management information systems at Hilo. I'm also part of Hawaii Data Science Institution. My research area are mainly natural language processing, artificial intelligence, and data science. And since I'm in the College of Business and Economics, I'm a computer scientist. So my main interest of research is actually how AI affects human and human decision making. So everything that I do with AI, I'm an AI person, but somehow I study the interaction between AI. So everything that I do has a human component. So a little bit about AI. So a couple of years ago, when I do a presentation on AI, I had to spend like half of the time to explain what an AI is, a large language model. But now I think most of you are aware of what an AI is and what large language model is, and actually you guys are using it. So I'll keep it brief, but let me share like a couple slides on AI that might be helpful to understand the project that we're doing right now. So you may think like especially for like the students, undergrad students, you may think that AI is new, it just came out, but that's not true. Actually, the AI, the first guy who used the term artificial intelligence was John McCarthy. John McCarthy in 1955 during a seminar at Dartmouth College. So he first used the term, and I think it became officially used from 1956. So AI has been around, what, 75 years right now? So it's not new, it's not new. But the thing is, like a lot of people, when they think of AI, the advance of an AI just grew like either linearly or exponentially, but that's not true. It has like a cycle. So in the beginning, the first concept of AI came out, and people were super excited. Oh, so we'll finally make something that is as smart as human, or we'll just do nothing and we'll make the AI do all our work so we can just spend that time for doing good stuff. That's what we expected. But they tried for a decade or two, and they realized, okay, that's not working. There's a possibly it's just impossible to make some computer that is as smart as a person. So it went down, but there were a couple of people who were still working on doing research on AI. So I think in like 2000, early 2000 or something, there's another big peak there because of a paper that is published by researchers at Google. I forgot his name, but this guy came up with a way to vectorize a word by Smith. That was like groundbreaking, and like people were excited, especially people in natural language processing field. And then the most famous paper when you talk about AI is the transform. Came out in 2012 or something, right? So attention is all you need. Right? The paper is groundbreaking, and upon based on that paper, now our next AI peak is that we are experiencing right now. Right? So 2020 that we are living right now is the generative AI era. That's based on the transformer and large language model. Right, so when people talk about AI, they use the large language model and AI interchangeably. They think it's the same thing because that's how we are making AI using language model. So it didn't have the large part before, so it's just called language model. And language model, if you think about it, it's not like fancy stuff. It's just a statistical model that is trained on not even large, just on text data, and it reads all this sequence of words in the data set. And what it does is, given a sequence of words, like this one here, the quick brown fox jumps. And what it does is it just pulls the list of words that will probably come after the sequence of words. That's all it does. Okay, so for example, this one, the word that has the highest probability of appearing after these words is over. So that's how the language model works. So it just puts over there, right? And now your sentence becomes the quick brown fox jumps over. Then what it does is it also tries to predict the most likely word that will appear after the quick brown fox jumps over and puts the word there. And it keeps going until it finishes the sentence or paragraph or done. That's what it does. So basically, that's what ChatGPT is. So you type something that becomes a given sequence of word. And given that, the ChatGPT just finishes the word by guessing the word that will come after your prompt. That's what it does. Right? That's the basics of language. Now, some people, what they did was, okay, so language model is just auto correction or something that we use. But what they did was they just increased the size of the model to like billions of parameters or even trillions. That's all they did. They keep the fundamental of the model the same, which is guessing the word that will come after the list of words. That's it. But the researchers, they start to see something remarkable. All they did was just increase the size of the language model. Right? So the language model is not just finishing your sentence, but you can see it start to reason, it start to write a computer programming code, it start to translate your sentences, it can even summarize the whole document into paragraphs. It's called emerging abilities. So no one expected this. All they did was just make the model bigger and feed more data into it. And somehow this language model, now we call large language model, became really smart. Right? That's all we did. So large language model is the ChatGPT or Gemini or a Cloud or something. And that's when people start to believe that, oh, okay, so if we make this large language model as smart as possible, then maybe we can actually make artificial intelligence that is as smart as a person. Right? That's where it came from. So now it wasn't like this before, but now when people think of AI, they think of this large language model. And we call this the generative AI because it generates the word that comes after the sequence of word. So that's where the generative word comes from. So people are excited. Okay, so now let's buy GPUs, let's have more data, let's make the model as big as possible, and we'll make something that is as smart as a person. That's our expectations. So like ChatGPT 3.5 came out, 2-3 years ago. They increased the size of the model by buying a lot of GPUs. So NVIDIA, the stock prices went up a lot. So that's what they did. And people are starting to realize that even though we increase the size of the model, it's not getting as smart as we expected. Okay. And increasing the size of the model requires a lot of resources, money, and time and data. So people start to believe, okay, so maybe we cannot do this by increasing the size of the model forever. So we are kind of hitting the wall, right? Okay. So actually, this is what we are doing in our project is that, okay, so we are hitting the wall. And as a university, obviously there is some kind of limitation that not like the OpenAI, Google, or Microsoft, we don't have that much resource that we can put in making those AI. So what people are looking at right now is, okay, so instead of making a super large language model, what about we use the model that we have right now, which is not as good as a person, but it's still smart enough. So how can we use this better? Right? So instead of one giant brain that will solve all the problems that we have, people start to build something called a team of an expert, which is called agent-based model. So instead of one massive general purpose large language model trying to do everything, we use multiple smaller and specialized models to solve the problem that we have. So in here, each agent, not like the ChatGPT, has a specific job or specific expertise that they're good at. Right? So they only need to do that specific job. They don't need to do any other stuff. So they are doing it really well. That's what we're trying to do in our project. So 20, 30 years ago, when I first started study data science, the major problem was how can you get data? Right? How can we get data so we can solve this problem? So we want to solve this problem by using data and statistics and mathematics. But the problem was we need data to do it. And 20, 30 years ago, we didn't have that much data that we can use. Now, because of the internet, because of smartphones, because of all the sensors that we have, we just have too much data. So we have so the models 20, 30 years ago, like machine learning models that we use are specialized in doing the stuff using a small set of data. Right? So support vector machine, linear regression, all those things that you learn in statistics class, they kind of focus on, we are trying to do the test better by using a small set of data, right? But the trend has changed, right? We have so much data that we cannot even process. So instead of focusing on the models that are good at solving problems with the small data set, we start to come up with the models that are powerful if they have a lot of data. It's called deep learning models. Right? So we have so much data. Actually, the deep neural network used to be just a neural network. It's not you. It's just like a linear regression and random forest or support vector machine. It's just like a one machine learning model. But what it is good at is it can be large if you have a lot of data, right? And it can do a lot more things if it has enough data. So now the problem is, okay, we have too much data. How can we use all this data that is available to us to make a better decision? So the problem that we have right now is, okay, so we have so many different sources to get data, and usually they are siloed in their sensor or their database or something. So we don't have that much ways to combine these data sources so we can make a better decision. So it's like back in the days, we just look at the gas data right there in the middle, and we use support vector machine. So okay, so this is what the machine support vector machine has predicted. We'll go with it. Okay? So there is another project that just use, I don't know, vibration data, and just look at it, use linear regression, and it comes up with the decision. Okay, so this is the decision that we have. We'll go with it. Right? So now, now we have all this vibration data, gas data, visual data. So we are trying to think of a way, okay, so we have so much data, how can we use all of those to make a better decision, not just looking at one source of data? Okay. So that's how we came up with our VULCAN-AI. And by the way, I gave ChatGPT what we were doing, and I asked it to come up with a cool name in a Hawaii context to represent our project, and this VULCAN-AI is what it came up with. And actually, I'm from Hilo, and we have a VULCAN team, so it's perfect. So I'm using it. I did. So this is an AI generated photo. So like 2 weeks ago, there was a big eruption on Kilauea volcano. I went there, and this is the video that I took. Right, it was fascinating. So the news article on this was on the left side says Kilauea volcano shoots lava as high as the Empire State Building. Right, it was that high, and I fed that news article title into, I think it was Gemini, I forgot which one it was, into Gemini, and asked it to generate a photo that represent the title of the news article, and this is what it came. The volcano, and there's like Empire State Building. It's not. It's not. Okay. It's not. Okay. So in the beginning, with all this ChatGPT, Gemini, and everything, we had this problem of predicting the eruption of volcanoes, because that's what we have in here on Hawaii Island, right? So we have two large volcanoes, and one of them is still really active, and I think there was a large eruption in 2019, right? So it is it's not that dangerous though, but it is actually a problem to the community. So I approached USGS and saying, okay, so we have all these new AI models that we can use, because I know the person who works at a USGS, and we had a meeting, and he explained. So if you subscribe to their website, you get this report whenever there is an eruption at one of our volcanoes, or if there's a large earthquake near us, so we might have a tsunami warning or something. So I asked him, okay, so I'm getting this report a couple of times every day. How do you guys write the report? And the person said, I'm the person who's writing the report. So I look at the data, the video live stream from the volcanoes. I analyze them manually on my smartphone, and I write the report and email them to the people who are subscribed. Right? So I told him, okay, so what if the volcano erupts, I don't know, like 4 a.m. at night? And he said, I wake up and I look at my smartphone and write the report and send it out. There's basically one person who is doing it. So I said, oh, now we have all this smart AI that we can automate this. Okay? So we met, and I explained the things that the AI can do, and we tried it. So I asked him to provide all the data that he used to write the report, and we fed it into this large AI model, and actually it fails to come up with any meaningful conclusion or prediction, because there was so much data. First, they have this live cam installed at the crater of the Kilauea volcano, like three of them. And it's streaming, I think, in the 4K, right? So it's a lot of data. It's a live streaming of 4K video from three different cameras. There's a lot of data to process. And of course, they have these traditional data sources like seismic gas, vibration, satellite images, and everything. So we fed it into a large model, and it didn't work. Right? So he said, maybe AI is not as smart as we expected. So maybe let's not do this. So we waited a couple of days, and suddenly the team came up with the way something called multi-agent, which I'm going to explain soon. So didn't work. Putting everything into one large AI model didn't work. So what we thought was, okay, so if we look at how humans do things in an organization like company, instead of you make the CEO to make all the decisions, what we do is we have this special agent, small special agent for all the things that the organization do, right? And we collect their decisions, their data, and we make a final decision based on those. So, okay, so let's there must be a way that the organizations are structured this way. So why not we use the same thing, apply it to our problem? Right? So instead of a single large AI, our VULCAN-AI is a multi-agent system which has a bunch of small AI models, which is specialized in each task. So also there's like a hierarchy. That's how the organization is structured. So there is like a coordinate agent, which is usually like a manager or a CEO, and you have like a team leaders there, and we have team members. So we try to use the same structure of an organizations for ours. So there's like a special agent guild. That's what we call. It's a team of autonomous agents, each an expert in its domain, like gas, vibration, or life field. This decentralized structure makes the system robust. And we'll show you why it's robust. There's a coordinate agent that's like a manager that sees the big picture, right? Fuses insights and directs the team's focus. So this hybrid model combines the resilience of a decentralized network with the strategic focus of a centralized leader. That's what it looks like. So we have this specialist guild, one, agent in SAR and agent seismic, which just looks, so the agent in SAR just looks at the satellite, right? It doesn't look any other stuff. So it looks at the satellite image of the volcano, and it makes its own decision whether the volcano is erupting or not, based on just the satellite image. We have this other one, looks at the vibration data only, and it makes a decision based on just on the vibration data, right? So they are specialized in their field, and the only thing they need to do is look at their own source of data. They are a lot better than if you use one large model and try to do everything at once. Okay, so we have these two special agents. We also have this agent gas, agent vision, and we actually focusing more on the vision one in this project. So agent gas analyzed the data of gas. It smells the critical volcanic gases like SO2. And we also have the vision agent. Actually, this is the most advanced one that we have that actually analyze the images from the live feed and determines whether the volcano is erupting. And we're trying to bring more expert into this, like Hao Peng from UH Manoa, because he's the expert in analyzing the video stream. So instead of just using the images, we'll probably expand this to analyze the live streams as well. And this is kind of the whole part that we have. We also have an agent called agent indigenous. Right? So volcano, like our Hawaiian knowledge and wisdom on volcano. Actually, we can find this from the old newspaper, which is in Ole Hawaii, the old traditional Hawaii language. And there are a lot of wisdoms, knowledge, and information about volcanoes, about their eruption, how they overcame the eruptions and so on. So we're actually trying to build this agent that is specialized in, let's say, indigenous knowledge so we can embed it into our system as well. This is the normal part. And we use like also a bunch of advanced natural language processing for this agent as well. And the last one, I think this is the most popular one that people are looking at right now, is the agent citizen. So there are so much information out there on the internet, like Instagram, Twitter. It's not Twitter anymore, but it's Twitter, Facebook. If there's an eruption, right, there must be someone who's taking picture or talking about it on social media network. So we gather those data as well in real time. It's agent citizen, and agent citizen actually analyzes the social media platforms and feed its decision to our coordinate agent as well. So it looks at photos, videos, text, everything. So this is like a robust, specialized agent to analyze the social media. And of course, there is this AI project manager who looks at everything and comes up with one overall decision. So this is guy who looks at everything and merges them, and come up with overall decision. Okay. So we didn't expect this. Well, one of the biggest problem of AI is that, okay, so I use ChatGPT. I ask it to summarize a document. It does it really well, but we are not sure how it's doing it. It doesn't tell us, okay, so I looked at the document. I think the first one and second sentence are important because of this, so that's why I put it there. I choose these words, so on, so on. So it doesn't explain what it's doing, but it just given an input. It just gives you an output. It's good. If it's good, you're happy. But if it's not good, then you want to know why it's not good, but it usually doesn't tell you why it's not good. And if we use this large one giant AI. So we use this small special agents. And when it fails, we realize that, okay, we can actually see why it failed, because we can look at what each agent is doing and where it went wrong, right? So hold this big giant, which doesn't tell you anything, but we can actually go into our system and we can look at what each agent did, and we can actually identify which of those agents made the mistake, right? So it became a little bit more transparent and a little bit more explainable. And we can easily improve the system, because say the agent vision wasn't doing its job, we're going to and fix it or make it better so the overall system works. So somehow we didn't expect this, but we kind of got some transparency and explainability by using this multi-agent system. So this is what it looks like. So we have a 3-year life, which actually so we have 8 cameras, but 3 of them are publicly available on YouTube. So you can actually look at them. So this is actually the real-time live feed from the creator. This is one of it. This is a west. We have the south one here too. Okay, it's not erupting right now. It's like this, and that's one of them. And actually, we have even the vision agent. So there's like one agent that looks at each camera and analyzes it. But for one camera, actually, there are like 2 agents. So one is for the day and one is for the night. So there's like an overall vision agent that looks at each live feed, and it determines whether the time now is dark or light. Right? So if it's at night, then the way that you should analyze the live feed should be totally different, because it's at night. So it passes the information to the night vision agent, and make it analyze the light field. If it's at night, at bright daylight, right, then the main vision agent passes the information to the vision agent day. Then the agent analyzes the light field during the day, so it can actually make a better analysis. Okay. So here, that's how it works. And this is the communication part is not one way. So say from the left camera, we call that creator camera. It looks at this light field and say, oh, there might be a eruption, right? From that side of the camera. And it talks to the coordinate agent. And coordinate agent says, oh, you are saying that could be an eruption, but the other two vision agents are saying otherwise. So what it does is it actually orders the other two agents and say, oh, but the one of the camera agent is saying there could be eruption, so why don't you go and take a better look at the light field? So actually, they go and look at the light field more carefully and try to determine whether there is eruption. So it's like a two-way communication. So here, actually, I show you the real link. And if you see the bottom, that's actually the narrative that the vision agent came up with. And it's just a draft, but on the right side, that's what you get from USGS. If there is some kind of a thing going on, either earthquake or volcano eruption, right? So that's what you get. So we are trying to mimic this using AI, and the left one is what I came up with. It's not 100% correct right yet because it's a work in progress, but it was not too bad. Right? So of course we have to work with all the formats, everything, but it has all the things that you should. It's important. And this is the last one that we have is that through the SAGE sensor project funded by NSF, there are two SAGE sensors. One on Hawaii Island, and I think one on Maui. So I'll talk about it. It's just a sensor, and you might wonder why the sensors are special. So we have these two sensors, and I think they are planning to put 6 more sensors on in the state of Hawaii. I think that's what they're planning. The problem, the remarkable thing about these SAGE sensors is that it has its own GPU computation unit within the sensor, right? It's not as big as like a big server that you usually see to run those big AI models, but they're quite small. So it's a small, like a laptop thing. But our framework that uses this small AI expert, the thing is that we can actually run our small expert agent on the sensors. So we don't have to use like OpenAI, API stuff that needs internet connection and all those things. Instead of doing it, we can actually analyze what is happening at the sensor, right? So if there is some kind of communication failure, instead of sending the whole data to the main agent, analyze it there, and try to decide what we should do, we just process everything at the sensor, and only important things like there's an eruption or not is communicate to the main agent. Right? So even if there is like a communication bandwidth is going low, so instead of sending all the live feed to the main agent, we just say yes or no, saying there's an eruption or not. Right? So this SAGE sensors, combined with the Volcan-AI, we can actually try all the things at the sensor level. There and here. So we came up with the framework and prototype, and we actually tried to use this to analyze the data from 2018 eruption. Right, so we simulated the eruption with all the data that we can get, and we fed it into our work on AI, right? So this is the timeline, April 30th, crater collapse, May 1st and 2nd, earthquake, May 3rd, the eruption. So we fed here, if you look at the top, they are the type of data that you can get for each event. So we fed it into our work on AI, and it kind of worked well. Right, so let me see if I have the, yeah, so it is super fast than the manual detection. And the accuracy kind of went up a lot. So I make sure simulated and tried it, it works well. Even though it's a work in progress, it worked well, so we are kind of happy. And this is what actually what it's doing. It's looking at the live stream and trying to generate this report. Each agent is generating report. So now, and the last thing before we end, we have this work on AI framework, and we were wondering, okay, so can we just use this for volcano eruption detection? Can we use this for this framework for other stuff as well? And we look at this wildfire, this is starting to become a more critical problem to, especially to us, because we have a lot of dry places and in California. So this is like a work with my colleague from SDSU, San Diego State University, and their focus is they don't have an active volcano right now, so they have a problem of wildfire detection. Right? So I brought what we are doing with the work on AI, and they said, oh, it kind of translates into the wildfire monitoring problem. Right? So we have this satellite agent that can also be used with the satellite data for wildfire monitoring. We have this vibration thing that can be used for ground sensors. Gas is gas, and vision agent is vision agent. So it could directly translates into the volcano monitoring to wildfire monitoring. And if you are using big, large AI to do everything, it's kind of hard to adapt what you're doing to different problems. I kind of translated into, well, so here, so when we are doing the wildfire or volcano eruption, those called disaster detection, there are two problems. So if you took a machine learning class from either computer science or statistics department, you talk about this false positive, false negative, true positive, true negative, right? So your decision is whether to say there is a wildfire or not, right? And you have this system that says there is a wildfire when there is a wildfire, actually wildfire. So the system predicts that there is a wildfire and there's actually a wildfire. The system is correct. It's called true positive. Okay? And your system says, oh, there is no wildfire and there is actually no wildfire. That's true negative. So you are correct guessing there is no wildfire. The problem, those are okay. True positive, true negatives are because you're correct. That's not a problem. The problems are false positives and false negatives. So false positives are when you say there is a fire, there is actually no fire, right? So your system predicted there is a wildfire, there's actually no wildfire. So what happens then? Right? The firemen go to the site and you do all the stuff that try to take down the fire. So you are kind of wasting the resources by guessing there's a wildfire when there's not. But this is not that big of a problem because you just waste money. Nothing critical happens. But with our system, we can kind of overcome these false positives better than having one giant system. Right? Think about it. So we have a bunch of agents that looks at smoke, I don't know, heat, gas, and the vision. If one of them says there is a wildfire, and the rest says otherwise, you don't just say there's a fire, you go back and check, right? So because there are other agents that can check the different sources of data, even though one agent says there's a wildfire, you can check it. So it kind of minimizes the chance of having false positive because at least a couple agents need to agree to you actually say that there's one instead of one saying. So if you're using big giant model, and if there's one thing that says there could be a wildfire, and the model could just say there's a one, then there's a chance of having high false possibility. But having this multiple agent, you can kind of minimize having false positives. The bigger problem is false negatives, right? Because when your system says there is no wildfire, but if there is a real wildfire out there, then the consequence is huge compared to false positive, right? Because you missed it, right? So now, if you use big giant machine, there's nothing they can do because if it says fire, it's fire. If it says there's no fire, no fire. So there's nothing that you can do to the model. But for us, right, if false negative is very critical to the problem that you're solving, then we can make the system extremely sensitive by, okay, if there's at least one agent says there's a wildfire, then we can just say there's a fire, right? So this can work both ways. This is flexible. So if for your problem, if false positive is a huge problem, then you can tweak the agent, saying at least a couple agents need to agree to say that there is a. For this one, if your problem, the false negative is critical, then you can say if there's one agent, at least one agent saying there's something going on, then you will say there's something going on. So you will increase the sensitivity of the model. Right, so by having this multi-agent structure, right, you can kind of play with this. It became flexible depending on what type of problem they have. So we translate the volcano system to wildfire system, and vision is vision, gas is gas, and satellite agent is satellite. It directly translates into detecting the wildfire. And of course, there is this manager agent who looks at everything and makes the final call. Now, given all this, since I'm a professor who teaches AI at Hilo, briefly talk about AI stuff. So I know a lot of you fear that AI will take over all the jobs and the companies will just fire everyone and replace a human with AI. I get it, right? Especially for you guys, right? You guys have to, in your 20s, 30s, so you have to work at least like 20, 30 years. And for you guys, it looks very fearful and uncertain how the AI will change everything, right? So, what I think is that instead of having this big giant agent or the AI, if you have like a multiple small agent, we still need humans in the loop of the system because each agent is kind of mimicking what humans is doing. And you cannot just replace them because you have to know what the humans are doing. So instead of just replacing each person in their task, we kind of view this agent as a collaborator of all the people. So they'll do things that are here, right? So agent, when we look at this expert agent, the small agent, we are not referring just to AI. The agent is actually a combination of an AI and a human that becomes a small expert agent. So AI does this tirelessly monitor data, find patterns from the data set, run complex calculations. That's what the AI does as the agent. And human, as the agent, apply their wisdom, their experience, and the context of the problem. And finally, the human actually makes the ethical judgment to make the final form. So when we say multi-agent, each agent is not just AI agent, what we think it is, but it's a combination of an AI and human that becomes the expert agent. Okay? So we definitely need humans in our system that becomes agent. Right? So instead of replacing people, we're kind of aiding people to do a better job. Okay? So I know a lot of you are wondering, and there's a lot of discussion about whether we'll reach the AGI, artificial general intelligence, right? Which is AI that is as smart as a person, right? So everyone worry about this, and everyone is not certain what the work will be after we have this AGI, artificial general intelligence. Right? So there's like a cycle which I'll talk about later. But there are two types of people, two groups of people that one think, okay, so at this cycle, if we make the AI models big enough, we'll eventually achieve AGI. So in year or two, I think the OpenAI is saying in 3 years or something, we'll have AGI on AI that is as smart as person by increasing the size of the model. There are another group of people saying, no, that's not going to work. Right? So as you can see, this year and last year, just increasing the size of the model doesn't give you what you expect. So they're saying, oh, no, in this cycle, you guys will fail. You can make the AI very smart, but it's not going to be as smart as a person. Right? So there are these discussions. And this is it's an interview of the Meta, right? Facebook. You name AI chief. Yeah, I think he said, true intelligence requires grounding in the physical world, perception, action, and interaction. Not just a pattern in language, which is the large language. Right? So he's saying they can generate convincing answers yet lack real understanding, common sense, or the ability to reason about cause and effect. So he's saying if superintelligence demands more than words, what kind of system will be needed to build to get there? So he's basically saying whatever what we are trying to do, he doesn't think that we'll get to AGI by things that we are doing right now. So probably what he's saying is at this cycle, they say, oh, we may not reach AGI yet. Right? I kind of agree with him. Whatever we have, I don't think we'll reach AGI. We may. I think there's a 50-50 chance at this cycle. But the problem is, so for me, I'm kind of safe, so I don't think I'll work 20, 30 years more. So for me, I might be safer than you guys. But my guess is that the next cycle will definitely get AGI, for sure. Whether with the same structure architecture, by making it bigger with the, I don't know, like RTX 10,000 or something from NVIDIA. So if you have that big GPU, you may get there, but or there could be like a genius guy says, I'm giving you this new architecture for AI, not just a language model, but we'll definitely get there in our next cycle if it's not this thing. Right? So we'll definitely have AIs that are as smart as people. So that's going to be a real problem. Right? We have billions of people already, and we are having more people that is as smart as us. I think that's going to be a mess for sure. Right? But a lot of people are saying that is that what we want to do? right? Do we want to have more things that are as smart as us? We already have a billions of, right? So what people are saying is people should not aim for AGI, but it should be the super intelligent that is smarter than people, right? So when we have AGI, it's going to be messy. Trust me, it's going to replace a lot of the for a couple years or decades. That's for sure. It's going to be messy. It's going to be a mess. But once we have this super intelligence, and I'm not sure when we will have it or not, which is smarter than people, that's when things start to change. Because that's when the humans can actually do things that we are not able to do with human information. So AGI probably within decades or two maximum, but it's going to be messy for you guys and for me, myself too. But for once we get to the super intelligence, things will change. And I am quite optimistic it's going to be positive. That's what I said. So there. So where we are is the generative AI era. Well, not quite at the AGI yet. So we may get there soon or not. But eventually we'll try to get into the super intelligence, which is beyond human capability, discovers, designs, and designs. So it sounds scary, but I think it's going to be that scary. It's going to make us a lot better than expected. So don't be afraid of AI. It definitely has its limitations right now. So, I mean, what we're trying to do is, as a teachers or professors at university, we are not going to ask you to use AI, right? You have to use AI to survive. We are not going to do it. Or we are not going to say, you cannot use AI because you are going to be stupid. We are not going to do it. We are not people who are going to make the call. It's going to be yours. So what we are going to do at the university, of course, this may not reflect the view of UH system at all. It's my personal view. What I'm going to do is, okay, so we are going to teach you how to use AI better than ethics. Right? So we'll give you an option. We'll give you just not preventing you from using it. We'll give you an options, and you guys choose. You guys choose to whether to use AI or not. It's totally up to you, and you will decide. You will see later which things that you can use AI for, which things that you cannot use AI, and it's your call. It's not ours, but we'll help you to make that decision. That's I think what we should. Okay, so this work is partially supported by an SF4. Track 1, change UI, harnessing the data revolution for algorithms. And that's it. And I'm happy to answer any questions that you have. If you have any questions, or if you are a researcher who wants to do research on these topics, feel free to email me anytime. I'm happy to answer your questions or the emails. Thank you very much for listening to the lecture on Halloween.